Hello everyone, my name is Christopher Akpogome. You're welcome to the Chem Lab Chemistry Lecture. In our topic today, we're going to be looking at matter. Now, what is matter? Now, we say matter is anything that has mass and occupy space. Matter, anything that has mass and occupies space. Now, when we speak about mass, what we are simply talking about is we're talking about the particles that make up a substance. So matter is anything that is made up of what? Particles. And that same thing that is made up of particles can actually occupy a particular space. An example is what? Myself. Myself. So I as a person am matter. Why? Because I am made up of what? Particles. We said matter is anything that has mass. So I am made up of what? Particles. Now, what are my particles? I have my hands, my head, my legs, and the different parts of my body. And right now, where I'm standing, I'm actually occupying the particular what? Space. So that makes me what? Matter. Now, having said that, matter actually what has what different what properties, and these properties can be grouped into what two categories. So when we talk about properties of matter, we are simply talking about the behavior of what matter, the behavior of what matter under different what circumstances, under different what conditions. Now, the properties of matter can be grouped into two. We have what we call physical and chemical. Now, these are the two classes that the properties of matter are grouped into. We have the physical and we have the what? Chemical. Now, the physical properties pertains to the what? Changes that matter undergo physically. That has to do with the ones that we can see with our what? Eyes. For example, one of the physical change that matter undergoes is what? Color change. Now, color change is something we can see physically, so it's a physical change. And so, one of the physical property of matter is what? The color. Okay? Because it pertains to what we can what? See. Now, the chemical properties pertains to what? The reactions that matter actually what undergoes. So that's what we mean by what chemical what properties. So chemical properties are internal, while physical properties are what external. Chemical properties are properties that requires matter to go through some what reaction before we can actually see these what chemical properties, before we can actually what notice what these chemical properties. But for physical properties, we do not necessarily need to take matter through any form of what reaction before we can actually see the physical what properties. The physical properties are obvious, they are what visible, they can be visible to our what naked eyes. For example, I said at the beginning that I am matter. So now, if you look at me, there are certain properties or characteristics that you can point at. One of which is this: I am dark in complexion. Okay, I'm dark in complexion. I have small eyes. I have goatee. Okay, these are physical properties. Okay, these are physical properties. But now, when you want to talk about my chemical properties, you will need to look within me. Okay, and so what are my chemical properties? I have a heart. Now the heart is inside me, which you cannot see. Okay, so that's the major difference between what the physical properties and the what chemical properties. The physical properties are visible to the what naked eyes, while the chemical properties are internal. They are not obvious to the naked eyes, but the physical properties are what external. They are obvious to the what naked eyes. Now, the physical properties pertains to what? Physical change. While the chemical properties pertains to what? Chemical change. And so that brings us to the changes that matter undergoes. Now, matter undergoes two categories of changes. We have physical changes and we have what? Chemical changes. We have physical changes and we have what? Chemical changes. Now, the physical changes of that matter undergoes does not necessarily change the what? Components. Okay? It does not turn matter into another what? Substance. For example, if I have, or let's say, using myself as an example because remember I said at the beginning that I am matter. So if, for example, I said I'm donkey complexion. Now, if, for example, I start changing complexion and I start becoming what? Fair in complexion. Do you think my heart will change? Do you think my liver will change? Do you think I will stop being a human being? Are you getting what I'm trying to say now? So, my color changing, which is physical change, does not necessarily affect the internal part of me. Okay? So, physical change does not affect the what? The internal part of the what? Matter. The internal component of the what? Matter. But chemical changes actually affect the internal component of what? Matter. As a matter of fact, chemical changes turns the matter into another what? Form. Chemical changes turns the matter into what? Another what? Form. Chemical changes turns the matter into another what? Form. For example, now matter exists in three states. We have solid, we have liquid, and we have what? Gas. Now, when liquid changes to ice, that is a what? What type of change is that? That's a physical change. Yes. Why do we say it's a physical change? We say it's a physical change because it is the same substance. Okay? It is the same what? Water. It is made up of two atoms of hydrogen and one atom of what? Oxygen. So the chemical component of that matter, of that state of matter, did not change. Despite the fact that it changed from one state or from one form to another. Despite the fact that it changed from liquid to what? Solid. But the chemical composition was not altered. It still contains two atoms of what? Hydrogen and one atom of what? Oxygen. It's still what? Water. Are we getting it now? It's just what? The states that what? Changed. So that's a physical change. Okay? Now, we are going to move on to what we call classification of matter. Classification of matter. Now, matter can be classified into what? Three. So we have three forms in which matter what exists. We have three forms in which what? Matter what exists. Matter exists as element. It exists as compounds. And it exists as what? Mixtures. It exists as what? Mixtures. Now let's look at what? Elements. Now, elements is actually the what? Is a substance or is a form of matter that cannot be split into simpler units by an ordinary chemical reaction. Now, take note of the definition I just gave. We said it cannot be split into simpler units by an ordinary chemical reaction. Now, listen. it isn't that element cannot be split. No. Element can actually be split into simpler units. But if you want to split element into simpler units, then you will need something much more than an ordinary chemical reaction. Now, why do we say that? Now, in radioactivity, we have uranium, okay? We have radium. These are elements. And you will agree with me that they undergo radioactive decay. That is, their nuclei actually break. Okay? Their nuclei actually break. And if you can remember clearly, atoms are what? The smallest particle, right? Of what? An element. An atom is made up of what? A central part called the what? Nucleus. So it means that elements contains atoms. Okay? Now, through nuclear reaction, these atoms can be what? Broken down. Exactly. Now, I'm just trying to show you that elements can actually be split into simpler units, but not by an ordinary chemical reaction. That's why the definition says that elements are what? Forms of matter that cannot be split into what? Simpler units by an ordinary chemical reaction. So if you say elements are forms of matter that cannot be split into simpler units and you stop there, your definition or your explanation of elements is not completely what? Correct. Elements are forms of matter or are substances that cannot be split into simpler units by an ordinary chemical reaction. That part, ordinary chemical reaction, must be what? Included. Exactly. Now, elements are made up of what? Atom. Okay? And we said atom is the what? The smallest particle of what? An element. We will come back to atom later in a later video. Now, we have talked on what? Elements, and we know that there are different elements. There are over 109 elements. Now, let's talk about compounds. Now, compounds are what? Made up of what? Two or more elements. Compounds are made up of what? Two or more elements. Compounds are made up of what? Two or more elements. Now, we said compounds are made up of two or more elements. Now listen, these compounds that are made up of two or more elements, now the element that makes them up can be the same or can be different. Now, example of a compound, we have hydrogen gas, H2. Now, if you check, remember we said something that elements are made up of what? Atoms. Is it not so? Now, if you check this is hydrogen. But how many atoms of hydrogen? We have what? Two atoms of what? Hydrogen. Remember, we said compounds are made up of two or more what? Elements. So, this qualifies to be what? A compound. Another thing about compound is that they can be represented with a what? A chemical formula. Yes. They can be represented with a what? Chemical formula. That's one of the things that differentiate compounds from what? Mixtures. Now, mixtures are substances that are made up of different constituents. Okay? They are made up of different what? Components. Now, they can be made up of compounds, elements, and other what? Components that are not what? Compounds, that are not what? Elements. An example is your palm wine. And your mixture cannot be represented with a chemical what? Formula. Okay? That's one major difference between what? Compound and your mixture. You cannot represent your mixture with a what? A chemical formula. So, example of a mixture is your palm wine. Your palm wine is made up of what? Organic compounds and other what? Various what? Components. Okay? So, that's that for what? Element, compound, and mixtures. Now, cast your mind back. We said something about elements. We said that elements cannot be split into simpler unit by an ordinary word chemical reaction. Now, mixtures, they are substances that are made up of what? Constituents, two or more elements and other what? Constituents. Now, this mixture can be separated by what? A physical method. Yes, this mixture can be separated by what? Physical method. So that brings us to our next discussion, which we call what? Separation techniques. Separation techniques. Now, separation techniques are actually what? The various methods that we employ in order to separate the various components or constituents of a what? A mixture. Okay, so in order to separate the constituent of what? Palm wine. In order to separate the component of what? Palm wine, we apply a separation what? Technique. Now, there are many separation techniques. I'm just going to list some of them. In our next video, I will explain each of them one after the other. So let's see. We have filtration. We have sieving. We have chromatography. We have crystallization. We have distillation. And a host of what? Others. etc. Now, in our next video, we are going to focus on the various separation techniques that we have. We're going to deal with them properly. We are going to go in depth. So if you love this video and you actually got something from what we talked about today, I want you to what? Like this video and give us a thumb up. And also, I would like you to click on the subscriber button and subscribe to our channel so that you can get more videos from us, so that you can be notified on any latest video that will be putting up in our next class. Thank you very much. Have a nice day.